Hey, we are going to look at what is necessary and what is required for things to be scale copies of each other. So, starting with these guys, we have Alice, who had kind of a weird thing happen. She fell down the rabbit hole. She ate a cookie. She became a giant. And then she ate another cookie that said eat me, and it shrunk her down. So, looking at these, they're all the same person, but are they actually scale copies? Is she the same in all shape ways? So looking at this, one thing I might want to pay attention to are some of the angles. We've got a lot of angles here. So I could look at ECD, for example. And if I look at ECD and measure that angle, you would find that that ends up being, I believe, 80 degrees if you use a protractor. And if you come over and you measure the same angle, a corresponding angle over here, it is also 0 degrees. And if you come over to Mini-Me, that corresponding angle is still 80 degrees. So in our different angles, or in our different copies, we end up with angles that are the same size. Yes, you might find that the legs are longer, but the angle measure is still the same in all of them. So that's interesting. Or that might be something that would help prove that they're scale copies. You could keep going if you wanted. You could look at things like this angle and say, oh, they're right angles in all of them. And you could use a right angle something to check that. So let's pay attention to some distances. Why don't we do that? The head, because it's a circle, that's kind of challenging to find the distance around. The legs are a little bit challenging too because they go across a square. But let's look at distances that we do know. We can use those to think about whether there's a scale factor. So let's look at AB in Alice. AB is her arm span. So if we look at AB, this distance here is 2. Now if I go over to the giant, 1, 2, 3, we have LM equals 3. Let's see if I can get that down anymore. And then over in Mini-Me, UV is equal to 1. How about height now? If we look at the height, Alice's height is 1, 2, 3, 4, 5, which we've got here. The giant's height is 1, 2, 3, 4, 5, 6, 7. Doesn't come all the way down. It comes halfway down that box. So the height for the giant would be, the height for the giant would be 7.5. The height for the Mini-Me would be 1, 2, also doesn't come all the way down. Height for the Mini-Me would be 2.5. And to just get in what we were missing there, that UV, like we said, would be 1. So the question is there a scale factor here? Well, where are scale factors here if they exist? Because we have 3 different figures. So let's see if we see things that we could do easily. Going from Alice to Mini-Me, we go from 2 to 1. Going from Alice to Mini-Me's height, we go from 5 to 2.5. In both of those cases, it's like we took and slashed in half. Her height is split in half, her arm length is split in half. So I would call that a scale factor of 1/2, or I'm taking 1/2 of the original to get the new copy. So we've got a scale factor of 1/2 there. Well, now that we're at 2.5, and now that we're at 1, to get from the Mini-Me to the giant, is there a scale factor here? So to get from 1 to 3, I could triple it, or times 3. And that works here as well. 2.5 to 7.5 also triples. So I can do times 3 as my scale factor to get from the Mini-Me to the giant. So then that just leaves us with Alice to the Mini-Me. Alice to the giant. If we take 1/2 to get down to Alice and then multiply by 3 to get to the giant, we're now taking 1/2 times 3, which is going to be 3/2. So from Alice to the giant, we would have a scale factor of 3/2. Each one of these is what we would call a scale factor, because that is telling us how we would start from some original and go to the new copy. And that scale factor is going to be multiplied. We take half of something, that would be saying times 1/2. So that's what's going on with Alice. Looks like, yep, all of those are scale copies. So let's take a look at these W's for Wonderland. So in these W's, we aren't on a grid anymore. We have lengths provided still, though. So in this case, we know that AB is 6, and we know that HI is 15. We also know that the larger one is a scaled copy. So we can assume that there must be a scale factor. So to find the scale factor, I need to go from the original 6 to the new 15. And there are a couple ways I can look at this. I could look at this as 6 times what is going to get me 15, which then could lead me to the relationship 15 divided by 6, if we think fact families, is going to tell me what that is. Or I could say, how many times, if I had 6, how many times would I need to stack it to get to 15? So if I did 6, and then I did another 6, now I'd be at 12, and did another 3, now I would be at 15. So this is like having a whole and a whole and a half, which would be 2.5. Or in this case, 15 divided by 6, that would give us 15 over 6, which would simplify, if we divide all by 3, to 5/2, which is also equal to 2.5. So we have a scale factor of 2.5. So now, if AE, a distance that we have just between two points, if that's 4, how could we get from there to HL, its corresponding distance? So we have 4. We have a scale factor, 2.5. To get the new distance, we can just do 4 times 2.5, which would be like doing 4, and then 4 again, and then half of 4, or 2, which would get us 10. Now, if IK is 5, this one's a little bit different because IK is in the copy, not in the original. So if IK is 5, right here, that's 5. How can I figure out what BD is? So I know that something, because BD is the missing value, the original, times 2.5 needs to get me to 5. Well, people had some different ways of approaching this. I liked someone who noticed that this is, again, fact family related. Something times 2.5 needs to give me 5. I could also then turn that into a division problem, 5 divided by 2.5. And as we already knew from a previous problem, 2.5 goes into 5 twice. So our scale factor is going to be 2. Or excuse me, not our scale factor, our length of BD. Additionally, if you did 2 and then 2 again for the 2 holes, and then half of 2, which should be 1, you would get yourself back to 5. So that's a way to check that 2.5 times 5 is going to work. So that's what we can do if we have 2 drawings that we know are scale copies and we have one set of lengths. We can use that to find any of the other lengths as long as we're given some amount of information from either the original or the copy. So those are for things where we know they're scale copies. I'm going to give you one more. Looking at this, I want us to apply everything that we've just talked about. We've talked about angles and we've talked about distances. So looking at this, we have these two shapes that look pretty similar to each other. Are they actually scale copies? So I'm going to pay attention to lengths, looking for a scale factor. And I'm also going to look for angles. Are they the same? Let's start with lengths. The vertical distance, Jn, tells me how far down it goes. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And the corresponding vertical distance in the other polygon, 1, 2, 3, 4, 5, 6, would be connected there. Then the horizontal distance, xy, is 1, 2, 3, 4, 5, 6. And the corresponding horizontal distance in the other polygon is going to be 4. So is there a scale factor here? And we need to be willing to work with fractions. So let's say if we were going from the small one to the larger one, what would we need to do? 6 times what is going to give me 9? Well, we could turn that into its related division problem and get 9 divided by 6, which would end up giving you 1.5. Or you could look at it as, okay, I need to do 6 once, and then I need to do 3. And that's like having the whole 6 and the half 6, which would also be 1.5. So we have a scale factor of 1.5. Let's check if that works for 4. If I do 4 times 1.5, that's like having all of 4 and then another half of 4. 4 plus 2, that's 6. It checks out. So there is a common multiplier here, which makes me think maybe we've got a scale factor. But let's look at angles to be sure. So if we look at angle x here, let's get ourselves another color. If we look at angle x here, and then it would be good to like trace it and then bring it over, which I can't do easily here. But if you did that here, you would find that z is more obtuse. Z and x are not the same angles. So no, they are not the same. And if you measured them, you would get something like 100 and 120 here. That is all that you need to say that no, they are not scale copies. Because they are not the same shape if they do not have all the same angle measurements in their corresponding parts. Looks good in the distance on the distance side, but it is not actually a scale factor. You need both. You need a scale factor and you need to have the same angle measures.